We are back with even more practice problems. We have another predict the product practice problem. We have our starting material right here, our reaction conditions. Let's predict the product if you want. Pause the video, screenshot it, work through it on your own, come back, see how you did. If not, we're going to work through it together now and go over the mechanism. And before we do this, remember to like the video, hit subscribe so you get more practice problems, and send this video to someone you're in organic chemistry with. So, all right, right off the bat, what do we have? We have a can't talk today. Secondary alkyl halide. We have sodium ethoxide. I'm going to just redraw this real quick. Like that. And it's in ethanol and it's at reflux. So here, let's go through our checklist when we're looking at conditions in the substitution. Is this elimination? So we have secondary substrate. That could go either way. We have sodium hydroxide. I'm sorry, sodium ethoxide. Can't talk today, guys. This is nucleophilic, but it's also a strong base. And then we come down, we have a polar protic solvent. So, it's not really telling us much there. It's going to make the nucleophile less stable, so it wants to react. Same with the base. However, it is refluxing. That is key there. So remember, when there's heat or there's reflux, that is going to tell us it's likely going to be an elimination reaction. So this is going to be an elimination reaction. And because we said we have a strong base here, elimination reaction with strong base is always an E2 mechanism. Remember, E2 means one step. It's kind of backwards. E1's two steps, E2 is one step. So what's going to happen is this hydrogen here is going to get yanked by our sodium F oxide. And it's going to kick its electrons down there. This iodine is going to go kick itself off. It's going to form a sodium iodide salt. And we're going to form our product, which is this alkene right here. Now notice how this formed in the most substituted position, which is the more stable position. However, that form there, because remember, this is a small, non-bulky base. This is our Zaitsev product. If this is a bulky base, say potassium terbutoxide, the double bond would form here because it's going to have a hard time grabbing this proton. Remember, bulky bases lead to the least substituted product, there's your Hofmann product, and small bases lead to your most substituted, which is your Zaitsev product. So, all right, that should have been an easy one for you guys. Remember, when you see heat, always think elimination. And then if you have a strong base, we're going E2.